Uh, okay, hello. Today I'm going to be pseudocoding problem 1 in homework 4 so I can teach you the process of breaking down a problem into small steps and implementing that into code. So the hardest part about coding isn't the coding itself. You can search up the syntax and all that online. It's the logical thinking of how to break down a big problem into smaller and smaller chunks. Just like engineering. When you have a math problem, you take the small bits of information that you have, you use whatever formula, you plug that in, and you get your answer. So the hard part isn't actual plugging in the data. The hard part is getting the data from the problem, whatever problem you're working on, and using and identifying the correct formula and a lot of that jazz. But we're not here to talk about math. We're here to talk about coding. So let me give you an example. So when we do pseudocode, let me teach you what pseudocode is. Pseudocode is just a way to take a big problem, break it down into smaller steps, and it's basically a format for anyone who's trying to solve a problem in code. So basically, it's written in a format like how we would code it with blocks and lines and everything, except there's no actual lines of code. It's just it's like items in a to-do list. Like I have to do this, then I have to do that. It's like steps in a sequential order. So anyway, enough chatter. Let me get to the problem. I'll read it to you so you can hear it, and then I'll explain my thinking. So in this problem 1 dot product. In this problem, we will write a function named what? It doesn't say, that performs the dot product operation on two vectors. In mathematics, a vector is essentially a sequence of numbers similar to a Python list. Given two vectors of equal size, dot product of those vectors is calculated by multiplying corresponding elements of the two gradients and summing the products. As an example, consider vectors represented by the following list. Then a dot product of these two vectors would be 3 plus 5 plus 4 plus 2, yada yada math. Write a function called dot product that takes two parameters named x and y. The parameters are tended to represent vectors of the same size. Function should calculate and return the dot product of these two vectors. The function should not print anything. The function should not create any new lists. It should not alter any lists provided to it as arguments. It should only involve a single loop. We will now test the dot product function. In a new code cell, create two lists named v1 and v2 as shown below. They give us the lists. Create and calculate the total dot product of these vectors. Print the result in the following format shown below. Match the format correctly. The dot product of v1 and v2 is blank. Okay, so this is the whole problem. Okay, pretty straightforward. So the first step of pseudocoding is to understand essentially how we get the output. All coding problems are basically input and then output. So our input, our input is basically two lists of arbitrary values. Let's say list A and then list B. I don't know if you can read that. I'll send a picture later, but for now, just listen to how I'm solving this problem. B will be 1, 2, and 3. So the dot product of two vectors is essentially, it's just going to be first list item plus second list item so on and so forth. Okay, so the product of two lists of the same length is we're going to have it's the first list items multiplied with each other plus the second list items multiplied by each other, and so on and so forth. Okay, so looking at this problem, it wants us to create. So what I like to do first is I like to think of what we need or what they give us. So they give us two lists, v1 and v2, and what we need is a function that calculates dot product. Okay, what they give us, two lists, v1, v2. What we need is a function that calculates the dot product. So we're going to get into the logic of what the function has. But first, let's start off with our pseudocode. So first, we need to initialize v1 and v2. That's our first step. And then we need to create a function. We need to create a function called dot product. So what goes in this function is dependent on what the function's intention is and what its output is. So we know the output, right? Output is the dot product. So that's going to be some sort of integer. All right, and the parameters we're going to be passing into this function is two params, x and y. They're supposed to represent vectors, but in this case, it probably refers to lists. So the first thing in problem solving for these problems is, they give us lists. The biggest takeaway is if you're working with any problem that involves lists, you're more than likely going to be using for loops. If you see lists, automatically think for loops, while loops, any kind of looping technique that basically allows us to iterate through the list. So we have a function, right? The output is the dot product, and we have two parameters. Okay, so the output is the dot product. What is the dot product? The dot product is the first item in each list multiplied with each other, plus the second item of each list multiplied with each other, and so on and so forth. Okay, so I know that it's the nth item of each list multiplied together. So think, if it's the nth item of a list, we have to index that list, or basically reference the value in the lists. And we reference values in the list with square brackets. So we have to do the math, okay? So this is where the pseudocoding, this is where we have to calculate stuff. So we need a for loop, of course. A for loop that traverses the length of, I guess, either list, because it's assumed that they're of equal length. For loop of length list. In this for loop, we're going to have the logic that calculates the product of each list item and then adds it to some sort of total. So okay, in this function, okay, forget the for loop first. We need a variable for total. Then we need a for loop of list length. In this for loop, we're going to add products of the lists together. Oh, multiply products, my bad. Multiply products of the list together. Then we add it to total. Okay. And after we do all the math, this for loop is going to go in each list. It's going to take the first value of each list, multiply together, then add it to our total variable. And then when the loop runs again, right, it's going to, oh shit. Okay. The variable, when you initialize the variable, we don't put it in the for loop. We put it outside the for loop. So I'm going to put that in our initialize step. So in our function, it's just a for loop that iterates through each list, and it adds the nth item of each list. It multiplies, it finds the product of the nth item of each list. So the first product of list A, then list B. Then it adds that to the total variable, which is defined outside of the function. Now this is important. I initially put the variable definition inside the function, right? But if we set that equal to 0 and the for loop runs again, every time it runs, it redefines total as 0. So we don't want that to happen, right? So that's why we initialize it outside and then increment it within the function. Oh, actually, no. Never mind. No, this is a function. This is a function, not a for loop, right? I'm being dumb today. And then we add that to total. Okay, after we do all the math in the for loop, after the for loop calculates what total is, we're going to return the value. So this is important. This is an important step because functions they're basically like if statements or blocks of code in a for loop. They basically tell the Python program when this function is called, these lines of code will execute given these parameters or inputs in the function. So what's the input? The input is two lists assumed to be the same length. The output is the dot product of those two lists. And the way we get to that dot product is created through this for loop that loops through each list, calculates the product of the nth item of each list, and then adds that to a total variable defined in the function. Then we return the value of the total variable. So that way, when we call the function and set it equal to a variable, it returns that value. I wish I had my IDLE to show you, but this is the best I got for now. Okay, then we just call the function, assign a variable that calls the function, And then we print the value of variable, in the correct format. Okay, I know I've been talking for a long time, but I promise you this will really help you in the long run. So our pseudocode steps. First, we initialize variables, lists v1, v2, and we create a function called dot product that takes two parameters, x and y, assuming they're the same length. We calculate the dot product and assign it to a variable, and we return that variable. Okay, the logic of calculating the dot product is in the for loop. And after that, we assign a variable to the function and call v1 and v2 in the function, calculate the dot product of that, and then we use a print statement to print out whatever statement they want in the correct format. I don't know. So this is basically the basics of pseudocoding. You probably can't read what I have written, so I'll send a picture to you. But essentially, pseudocoding is just taking a problem, writing down steps of what you do for that problem, and this is a good way to debug too, because you can work on these steps one by one and you can test it. And if something's not working, it's a syntax error, and okay, something's wrong here, something's wrong here. I'm gonna have to teach you how to debug too, but that's for later. And the good thing about pseudocoding is you can do these problems step by step. And if you're stuck on one, you're like, oh, I don't know, how do I initialize a variable? You can search it up on Google and learn. Okay, you have to call the variable name, then you have to assign it a value. Okay, how do I create a function? What does a function do? Oh, you can Google search that and then understand, like, oh, okay, the function is just lines of code that just output something. They take input and then they return an output. So coding is daunting because coding is essentially taking small blocks. It's like asking someone to create the Mona Lisa with tiny Legos of different sizes and colors, but essentially they're supposed to create this grand thing. And the hardest part about coding, I always tell people whenever they start out coding, it's not the syntax, because you can Google search that. It's the logic and breaking down these problems, the steps that you can execute and you can test. And the scariest thing about, or the thing that trips up most people about coding is there's no memorization involved at all. I used to think I had to memorize what this function does, what this function does. I knew when I first started coding in college, I knew what the functions did, but I never knew how to apply them because I didn't understand the concept of what it is that they do. I didn't really understand functions because I didn't understand, these are just lines of code that execute when you call them and that return a value. They take input, return an output. I understand them now. Back in college, I just thought a function was just this magical thing that spits out a number if you use the correct formula. There's no formula. There's nothing to memorize. It's all about understanding and applying the small concepts of what you understand. While loops, for loops, variable declaration, conditional statements, applying that to solving basically problems. So this is the part where I start giving you tips, especially for beginner coders. So a lot of beginner coders, they struggle a lot mentally because they sometimes they go into it thinking, I'm good at math, I should be able to learn how to code. In reality, coding isn't there's math involved, of course, but the fundamentals of coding, it has almost, there's math, but it has little, or there's no advanced math. You're not doing calculus in code. So, but just know that coding is hard. Like it's hard, and I make it sound like it's easy, but I've been doing this for a long time. When I first started, I had imposter syndrome too. I cried to my parents all the time. I thought I was going to fail a class because it's hard, and I had to work with 2D arrays and all this other bullshit. I worked in MATLAB and it wasn't fun, but it's a hard skill. You know, I think 3% of the world knows how to code, and by you learning this, you're going to become part of that 3%, and I think you should be proud of that. Another tip, that's to help you for your mentals. This shit is hard. Another tip is, since you're beginning, start early, like early. Like if an assignment comes out, just start it right away. Look at the problems, read what they want to ask you, and then look for patterns. If you're working with lists, if you see a list, you're more than likely going to work with loops, with for loops, while loops, whatever. If you see like words like if is a big keyword. If you see if, you're gonna have to use if statements. If it's like if this is greater than, equal to, or you're gonna have to use uh like the opera nah, the fuck, why can't I think? I'm sorry. You're going to use the equality sign, like the comparison operators. um just look for patterns and then try to pseudocode every problem. Like it might take you a long time and it might seem tedious, but I promise you, if you correctly pseudocode a problem, the coding is only going to take you like a couple minutes. Like, and also don't be afraid to ask for help, whether or not it's the internet, professor, friends. You know, people want to help you. You just gotta learn how to ask. And the best tip I can give to I give to anybody that's struggling in code, just don't give up. Like, honestly, it's a hard thing, but if you learn the fundamentals and like understand programming knowledge, you're not just going to be a better programmer. You're just going to be a better problem solver overall, and it's just going to it, and I think it's exciting that you learn all this knowledge and it benefits you, because you can take this knowledge of solving problems with you in your engineering degree or your personal life or whatever. So there are definitely benefits of learning how to code. Just if it seems tough, just don't give up, because I promise you, a lot of coders at one point in their career or in their time coding, they wanted to give up. I know I was one of them. I was in my school. I did honors coding. I was the dumbest person there. I failed every midterm. I failed every project. I still ended up with a B minus, because miraculously in the final, everything just clicked and I understood. For once I finally understood, like, I understood how to apply the small blocks of things that I learned to solve big problems. So yeah, I'll just send you a screenshot of this. I hope this has been informative. I know it's long, but trust me. I know you're not interested in coding, but trust me, this stuff goes a long way. Alexa, hacker mode.